A quick video response to a question 30, asked by Professor Lewin, and regarding something Newtonian in action, about force and its effect on a spherical object. What isn't described in kind of a perfect world kind of circumstance. So I'll attempt to use a drawing to illustrate that, what the exact questions are, and I'll offer just my intuitive without any knowledge of correct formulas or any, you know, how I would dissect the problem. So his problem is basically using a ball rolling on a frictionless surface, which I think creates some perceptual problems in terms of understanding skid. Because part of the question is if a force hits the ball, the little F arrow, and where it hits it is going to decide how much it skids versus how much it rotates, and that's sort of what's trying to be dissected as an answer to the problem. And so the obviously is looking for a formula, not necessarily an answer, because none of the values are given: the mass of the object, the force that's hitting it. And it's just really a formula to decide what will happen if the force hits different locations. So the idea is, if I hit the center of the ball, what happens? If I hit the edge of the ball, what happens? Those are sort of obvious ones as questions to answer. The difficult one is to answer the speed of the rotation at any specific location you do hit it at, versus the movement, how fast the ball actually moves or the thing moves. So the way I was thinking to better illustrate the problem is to think of it as a spaceship, and that you have some sort of thruster that's not aligned with the center of gravity or the center of mass of the object, and how much that non-alignment would cause the spaceship to rotate instead of to move forward. So I guess I would obviously say that intuition says that if you are aligned with the center of mass and you have a thrust, that you won't have any rotation, and all of the motion from the force will go to forward momentum, and the rocket works really good. Now if you have the thruster not in line with the center of the mass, then you will have a percentage of rotation and some skid. So you'll get some forward motion by percentage and some percentage of rotation based on how much mass is above or below the line at which you place the force. And depending on how much mass there is, above and below will decide the ratio of what percentage of the force goes to forward motion and what percentage goes to rotation. Now his direct question was, where do you hit the object to create all rotation? Well, I think the sort of obvious answer would be at this very top edge, and more easily illustrated if I stuck an antenna and put the thruster on the end of the antenna, you can really understand that all of the force would go to rotation. So obviously the higher you go in terms of on the surface, the further away you go from the center of the mass, the more rotation, and the rotation would be all rotation if you can get right on that edge, which I don't know if it's terribly practical, but it's probably doable. Tie a little bottle rocket on there. Now the question of percentages versus sort of has to be decided. You have to turn this force, as I would do it intuitively, is turn the force into an object of the same size. That is, convert it into how much speed would an object, if I turn the force, if I gave an object the same size as this object, the force, and then just thought of it as like a cue ball hitting another cue ball, all of the force will be transferred. So if I find out what the speed would be if I tried to move an object this big with that amount of force, then I can figure out how much total force there is, and then you're just doing this percentage argument. Now for the difference between the rotating speed versus the speed of forward motion, that just comes down to the difference between these two lines. so the rotating speed, if it was all rotation, it would be this length of lines ratio to this length of lines ratio. So it's some sort of 2/3 thing or whatever, 3/8 or whatever the percentage, the ratio is. So somewhere that's a Pythagorean thing of some, no doubt. But that's really will define the difference in the speed. So if the force all went to forward motion and say it turned out to be 50 miles an hour, and then you changed it to just rotation, the rotational speed, I guess, would be something like 65 miles an hour. Some kind of ratio like that. But that's how I would dissect the problem. So I want to keep this brief, but I did want to ask Professor Lewin a question, if I may, or pose something or other. There's a lot of people that talk about ferrocells, and there really isn't any scientific explanation on the internet about how these things work. I mean, I haven't seen any physics person dissect the ferrocell and explain what the optical effect is being caused by. I would argue that it's the little magnetic bits are actually diffracting the light by creating mirrors, two-slit experiments, and that the change in the angle of the light is causing a bunch of internal reflections in the glass that's actually creating the phenomenon. But obviously I don't have all of the, I can't draw it yet because I don't know enough about those specific phenomenon. But it is sitting out there, and people are using it to say light is bent by magnetism. They're using it to say a lot of things, and somebody in physics ought to explain what a ferrocell is producing, instead of just allowing people to wildly speculate about what they think is happening. So I'd appreciate that if you could do the explanation. So anyway, till next time and such and so forth and whatnot.